Section 5.4, Sum and Difference Formulas. What these formulas allow us to do is they allow us to, again, break free from the unit circle a little bit and solve for angle measures that are not explicitly labeled on the unit circle with x and y coordinates. How we do that is we look at sums and differences. So angles that are on the unit circle, can we add two angles together or subtract two angles to get the one we're trying to find? Now you have reference to these, so I do not believe you need to memorize them because there are a lot of little subtle differences. So you want to keep these out and be continually referring to them. So sine of two angles added is the same as sine of the first, cosine of the second, plus cosine of the first, sine of the second. And if you are subtracting with sine, that plus just turns into a minus. The cosine formulas and the tangent formulas, they all have their own little differences, so make sure you're continually referring to them. So let's take a look here. Find the exact value of sine of pi over 12. All right. Now, there's a couple of ways that you can go about this. Pi over 12, or you can think about it as a degree measure. Pi over 12, that is half of pi over 6. Pi over 6 is 30. Half of 30 is 15 degrees. So you can do those conversions if you want. It makes more sense to you. Now, pi over 12 only separate from two different angles by a pi over 12 amount. If you take all the values in the unit circle, pi over 6, pi over 4, pi over 3, and make them denominator 12, you get 2 pi over 12, you get 3 pi over 12, and you get 4 pi over 12. Had to do that little thinking for a minute. So 2 pi, 3 pi, 4 pi. Those, when you subtract them, would leave you with 1 pi over 12. So you could use pi over 4 minus pi over 6, because that is the same as 45 degrees minus 30 degrees. So what we're going to do, this is going to be our u value. This is going to be our v value. We're using a difference. We are saying that sine of pi over 12 is the same as pi over 4 minus pi over 6, which means we're going to use this formula right there. So I'm going to copy everything down. So sine of my first angle, sine of pi over 4, cosine of my second angle, cosine of pi over 6, minus cosine of my first, sine of my second. Now all of these values are from the unit circle, so I can evaluate. So I get a root 2 over 2, I get a root 3 over 2, I get a root 2 over 2, and I get a 1/2. So root 2 times root 3, root 6, over 2 times 2 is 4. Root 2 times 1 is root 2. 2 times 2 is 4. So to just put that together, root 6 minus root 2 over 4. And I have my exact value. I'd say the trickiest part of all of this is finding the angles that add or subtract, especially if you want to work with the radians, because it's a little different way of using your brain, okay? But once you have your u and v values, which formula are you using? Are you using a subtraction or a plus? Which function, sine, cosine, tangent? You find your formula, you write it all out, you simplify down. All right. So as you look through the notes, there's a couple more examples, A and B. You can check my completed notes online for the answers to those. I think you'll be pleasantly surprised when you get there. at the bottom, go ahead and verify this equation without using a cofunction identity. What I mean by that is think about using this substitution, the difference for cosine. Using the sum or difference formula, can you verify the cofunction identity? Over here, solving this equation, solving for x. When you do those, you can also check the answers with my completed notes online.